Hello, students. This is Saxon Algebra 2, Lesson 49A, which they called linear intercepts. But as you can see, I don't like that title because it's like introducing a new terminology. We know these linear intercepts as y-intercepts. And so that's what I would call it. And I've given it a subtitle as well. And the subtitle is Determining the Equation of a Line Given a Graph where the y-intercept cannot be seen. Now, why can't it be seen? It can't be seen because the line in the graph does not cross the y-axis. Now, what kinds of lines do not cross the y-axis? The only kind of lines that do not cross the y-axis are lines that are parallel to the y-axis. They will never meet the y-axis no matter how long they are, but every other kind of line crosses the y-axis at some point. So why do we have a graph where the line in the graph does not cross the y-axis? It's because the line is too steep. But never fear, have no fear, algebra is here. Remember that if you have a slope and a y-intercept, then you have a line. Y equals mx plus b. And those pairs of x and y are any point on that entire line. Also, if you have a slope and a point, then you can find the y-intercept. And that's like the little twist in part A. Now, they don't give us an example, but they do give us a graph at the bottom of page 213, and that graph shows a line that's too steep to cross the y-axis. And so let's go ahead and find its equation anyway. So anyway, first of all, I'm going to look for some points that are on that line. I like to find points that like exactly cross, and there are some. So one of the ones that I see exactly crossing is right at 4, 0. So I'm going to use that point, and I'm going to put that point there. And then I see the point 3, 6. And that would kind of be up here. So this is the point 3, 6, and this is the point 4, 0. And so if we draw down our legs, we have that part, and here's the line coming down, but we don't need that to find the slope of the line. Now remember, the slope equals the rise divided by the run. Now, if we start from this point and we do the run is going in this direction. That's the negative direction. So the run for this one, well, we should say that this point right here, since we dropped the vertical, it's going to have the same x value, but it's going to have the y value of this one because we made a right angle here. So we've gone from 4 to 3 on the x-axis, and so that means the run is a -1, but we can see the rise is a 6. So we find out that the slope of this line is -6. You can get the same thing if you start from the top point. You could start from this point, and in this case, let's do that one, m equals rise divided by run. In this case, the rise is going down. That's the negative direction. And so in this case, the rise is -6, but now the run is going in the positive direction. So no matter which way we do it, we get the same slope. So now we are good to go because we're going to substitute into y equals mx plus b. And I'm going to be kind of fancy here and use this point to do our calculation. So y is going to be equal to 6. And we know that the slope is -6, and x in this point is 3. So we have that, and then we have plus b. We're good to go. we have an equation with one unknown we can solve. 6 equals minus 18 plus b. So we add 18 to both sides and we get 24 equals b. That's why we can't see it. It doesn't cross the y-axis until it gets to 0, 24. So our final answer for this, for the equation of this line is y equals minus 6x plus 24. And that's how you find the equation of a line when the y-intercept is not shown on the graph. I hope this helped you, and I'll see you again.